Hi friends, in this session we study about the differentiation of parametric functions. If x and y are given as functions of a single variable, example x is equal to phi t and y is equal to psi t, are two functions and t is a variable. In such a case, x and y are called parametric functions or the parametric equation, and t is called the parameter. To find dy over dx in case of parametric functions, we first obtain the relationship between x and y by eliminating the parameter which is t here in this example I am showing with respect to, then we differentiate it with respect to x. But every time it is not possible or the convenient to eliminate the parameter. Therefore dy dx can also be obtained by different method I will explain with this tutor tech example. So here you see we have to find out dy over dx when x is equal to a cos cube t and y is equal to a sin cube t. Here t is the parameter. So we have to differentiate dy over dx. So what we follow here, first we find out the differentiation of dx, differentiation of x is equal to a cos cube t with respect to t. So dx over dt we have to find out and dy over dt we have to find out. So first we find out dx over dt, because x is equal to a cos cube t. Differentiate with respect to t. We differentiate this function with respect to t. So we get here, therefore dx over dt is equal to ddt of a cos cube t. Implies that dx over dt is a coefficient of this cos cube t. So we take it outside here, we could write here now ddt of cos cube t. Now we have to apply here chain rule. Let u is equal to cos cube t and v is equal to cos t. So we see what happens now. Therefore dx over dt is equal to a into du over dv and dv over dt. We are applying a chain rule. Now applies to dx over dt is equal to a ddv. Instead of u we could write here, you look at here, I explain once again, cos t we could write instead of cos t v. So u is equal to v cube, we could write instead of cos t v cube. The cos t is equal to v, so it is v cube. So we write here ddv of v cube with respect to v, and ddt of, we know that v is equal to cos t, so it is with respect to t. So we have to put down here instead of v cos t. Now implies that dx over dt is equal to a v cube. If we differentiate v cube with respect to v, so we get here 3v square, and instead of cos t, if we differentiate cos t with respect to t, we get minus sin t. dx over dt is equal to a. 3 I am taking here, so it is 3a, and v, we know the value of v is cos t. V is cos t. Look at here, v is cos t. So we put instead of v cos t, cos square t minus sin t. Finally I write here, therefore finally we get dx over dt is equal to minus 3a sin t cos square t. This we have got here. This is our first equation. Now we differentiate y. Look at here, y is equal to a sin cube t. Now, because y is equal to a sin cube t, so we differentiate this with respect to x. Differentiate with respect to t. We have to differentiate this with respect to t, so dy over dt we have to find out here. Therefore dy over dt is equal to dt of a sin cube t. Implies that dy over dt is equal to, a is the coefficient of sin cube t, so we take it outside. Qt. Now we have to differentiate. We have to apply here chain rule again. So here we assume some things. Let w is equal to sin cube t, this whole function we are assuming w, and z is equal to sin t. So through chain rule I write this down. By chain rule, we have to differentiate this, so we apply this here. dw over dt we have to find out with respect to t, so we get here dw over dz into dz over dt. Here we have to apply in this way, so I write down here finally, therefore dy over dt is equal to a d w over dz into dz over dt. Implies dy over dt is equal to a. W, we know that the sin cube t, so we could write here in this way, w is equal to z cube. Instead of sin we could put here z, so z cube. With respect to z we will differentiate this, and instead of z we have to write down sin t, we have to differentiate with respect to t, so we put sin t. Now we differentiate this, dy over dt is equal to a, it is 3z square, and sin t we get here cos t. I substitute the value of z here, 3 I put in front, 3a, Z, we know that Z is sin t. I explain here again. Z is equal to sin t. So we put instead of Z sin t. Sin, the Z square, sin square t, and this is cos t. So finally we get, therefore dy over dt is equal to 3a sin square t cos t is our second equation. Now what methodology we will use to find out the dy over dx, I explain you here. Just a moment. Dy over dx is equal to dy over dt over dx over dt. So in this way we could find out dy over dx. This we have to use here. So therefore dy over dx, dy over dt we know that 3a sin square t cos t, and dx over dt, we have found out this earlier, dx over dt minus 3a sin t cos square t. Minus 3a sin t cos square t. Implies dy over dx is equal to 3 and 3a will eliminate each other. This sin t, eliminate this square, this cos t, this. So we get here minus sin t over cos t. And finally we get dy over dx is equal to minus tan t, because the sin t over cos t is equal to tan t. So we get here, in this way we could differentiate the parametric equation in the form of dy over dx. If the parameter is given theta t, any parameter is there, we could simplify in this way. It is very easy way to solve the parametric equation. Thank you.